Hey, all you cats and kittens out there. That was a little nod to all you Tiger King watchers. Let me see, what are we doing here? We are solving exponential equations without logarithms. Now, at this point, you're probably going, well, it's a good thing we're not using logarithms because I don't know what a logarithm is. Don't worry, you will. But not yet. Not yet. Okay, so we're going to use the properties of exponents to help us solve each of the following equations. So there was a method to my madness last week when I had you doing all those exponent rules. So this one's not really so much an exponent property as it is just common sense. If I have 5 raised to the 3x and 5 also raised to the 6, and I'm telling you that they're equal, logic says that if the bases are equal, then the exponents must be equal also. So 3x must equal 6. We can solve that equation and get x equals 2. Okay, same idea applies over here. We have the same bases. Now, if there was something added on here, let's say like a plus 5, then we wouldn't be able to use this little trick. And that's going to be where logarithms come into play. Actually, we could probably do this one a different way without logarithms, but we're not going to worry about that right now. Okay, so again, same basis. That must mean that the exponents are the same. So I can set 2x minus 5 equal to 6x. And then we can solve that. I am going to take the 2x over and get that negative 5 is equal to 6x minus 2x, which is 4x. So x is equal to negative 5 divided by 4. So when x is negative 1.25, this equation is solved. Why is it zooming in and out like that? I don't know. Okay, number 3. We have a little bit of an issue because the bases are not the same here. So I am going to leave the left-hand side the same, but the right-hand side, I recognize that that is 4 to the 3rd power. So I can rewrite it as 4 to the 3rd power. If you're sitting there going, I would never have recognized that, I don't know that, don't worry. In the practice problems document, I have a whole table of common powers that you should be familiar with. And if you're not familiar with them, at least you'll have them in front of you while you're doing this assignment. So you would have been able to see that 64 is the same thing as 4 to the 3rd. Now, since our bases are the same, we can just jump right to setting our exponents equal to each other. And we get that x is equal to negative 5. All right, same thing over here. Bases are not the same. However, I do know, and you would know this if you were looking at the table, 27 can be rewritten as 3 to the 3rd power because 3 times 3 times 3 is 27. But that's still being raised to the x minus 2. So all I did was rewrite the 27 as 3 to the 3rd. Anybody out there know what 81 can be rewritten as? If you said 3 to the 4th, you are correct. But I still have the 5x plus 1 on the outside. Okay, now here's where our exponent rules are going to come into play. If I have a power and I raise it to another power, what do I do with these? So for instance, if I had 3 to the 2nd to the 4th, that's the same thing as 3 to the 8th. We multiply when we have a power to a power. So we're going to multiply 3 and x minus 2. That's going to give me 3 to the 3x minus 6. All right, I'll let you think about that for a second. 3 times x minus 2, you got to distribute the 3 to the x minus 2. Which means on the other side, I'm going to get 3 to the 20x plus 4. And then at that point, since our bases are the same, we can jump to 3x minus 6 equals 20x plus 4, and I'm running out of room here. Taking the 20 over, that gives me negative 17x equals, take this 6 over, that gives me a 10. So x equals negative 10 over 17. That's the answer to that problem. I'm going to give myself enough room here. Okay, so let's take a look at number 5. We have 125 to the x and 1 divided by 625. Well, I know that both of these numbers can be rewritten as a power of 5. 125 happens to be 5 to the 3rd, still being raised to the x. And 625 happens to be 5 to the 4th. All right. So on the left side, I have, whoa, it just got really dark in here. I don't know why. On the left side, I have a power to a power. I can rewrite that as 5 to the 3 times x. And on the right-hand side, I can use my negative exponent property. This guy's in the bottom, but I need him to be in the top. So when I move him up to the top, I can make the 4 a negative 4. Okay, so kind of like that negative exponent property backwards. And now since our bases are the same, I can write my exponents equal to each other and get an answer of negative 4/3 for this problem. Okay, I am going to pause the video. I'm going to let you try to rewrite the 8, the 16, and the 2 with the same base and see if you can simplify it down a little bit. So go ahead and pause the video. I'll pause my video, and when we come back, part of the problem will be done. Okay, so hopefully you paused the video and you actually tried this. 8 can be rewritten as 2 to the 3rd, and I still have it to the x, so 2 to the 3rd to the x is 2 to the 3x. 16 can be written as 2 to the 4th, so I have 2 to the 4th to the 5x, which is 2 to the 20x. And then 2 to the x plus 1 can't be rewritten, so it's just 2 to the x plus 1. We need to use a new rule here. I'm going to run out of room, so I'm going to come up here. When we divide powers with the same base, what do we do with our exponents? If you said subtract, you would be correct. So the left is 2 to the 3x, but on the right, I'm going to subtract these exponents. So 2 to the 20x minus x plus 1. And I wrote it in parentheses so that you know that we have to distribute that negative. So I get 2 to the 3x equals 2 to the 19x minus 1. Excuse me. So now we have the same base. I can set my exponents equal to each other. Taking the 19x over, I get negative 16x equals negative 1. So x equals positive 1 over 16 in this problem. Okay. All right. Number 7. Ooh, number 7 and number 8 look really challenging. We have a base 4, we have a base 6, and we have a base 16. These can all be rewritten with a base 4. So I'm going to pause the video, you pause as well, and see if you can rewrite with all base 4. And we're back. So hopefully you didn't do anything with this first one. The 64 can be rewritten as 4 to the 3rd to the 4x minus 3, and the 16 can be written as 4 squared to the 2x minus 1. I had paused there for a second because I just realized that these all could be written as a power of 2. That's 2 squared, that's 2 to the 6th, and that's 2 to the 4th. But 4 works. Whatever base you can find in common will work. Okay, so now I am going to move this out of the denominator, which makes this 4 to the negative 5x plus 1. Think about why I put the 5x plus 1 in parentheses, times 4. I'm going to multiply this, so this gives me 3 times 4x minus 3 is 12x minus 9 equals 4 to the 4x minus 2. And I'm going to do one more step on the side before I move over. I'm going to distribute this negative. So I have 4 to the negative 5x minus 1 times 4 to the 12x minus 9 equals 4 to the 4x minus 2. Okay, so we have a little bit of an issue. I have 2 bases on the left side of this problem and 1 on the right. Kind of like what we had up here in this problem. I had 2 bases on the right and only 1 on the left. Here I used my division property and I subtracted my exponents. What do you think we're going to do with these 2? Well, if you said that since it's multiplication we're going to add these exponents, you would be correct. So I get 4 to the negative 5x minus 1 plus 12x minus 9. All I did was add these 2 exponents equals 4 to the 4x minus 2. All right, so let's do this. 4 to the negative 5x plus 12x is 7x. Negative 1 plus negative 9 is negative 10. And the 4 to the 4x minus 2 stays the same. And now we're going to jump. We have the same base, so I can jump right to the exponents. 7x minus 10 equals 4x minus 2. Bringing the 4 over to the left and the 10 over to the right gives me 3x equals 8. Right? 7 minus 4 is 3. Negative 2 plus 10 is 8. So x is equal to 8/3. All right, I'm going to pause. I want you to try this problem. When you unpause, the problem will be solved. Okay, I'm back. I'm getting ready to reveal the answer. Hopefully you got negative 7 over 22. If you didn't, pause the video and see if you can follow my steps down the left and then my steps down the right. I hope you learned a little bit.